A and X is an element of B, and this is how it's written. So I hope you can see it perfectly. Yes, you can. So basically that's what it is. So basically that's what it is. So now you'll understand. So now you already know how to take two common elements in an intersection. I showed you that when I was showing you the union of sets. Now the reason why I did this faster is because I don't want the camera to again go off in the middle of this and then there'll be another big disruption. It would be a shame. That's why I did it fast. But don't worry, I'm going to take it slowly now. So I hope you've copied all of this down. So now I'm just going to take it down. Okay, so slowly as I continue teaching you, I'm not even going to say I hope you've copied this down. I'll just write it down, keep it on the board for maybe 2-3 seconds, and then I'll just erase it because I know you've understood it. So now we're going to talk about disjoint sets. Okay guys, disjoint sets are also a very funny sort of sets, okay? Disjoint sets. I mean, I find the name funny, you know. The moment I hear disjoint sets, I think what it would feel like if you dislocate your shoulders or your bones or something. You know, the word to me is a very creepy word, but don't worry. This is something which won't take much time, okay? So let's assume that A intersection B is a null set, okay? Then A and B are said to be disjoint sets. Are said to be disjoint sets, okay? Disjoint sets. Okay? So I hope you can understand that. Just excuse me for A and B. Okay. So A and B are said to be disjoint sets. So what does this really mean, guys? So yeah, let's assume A intersection B is a null set. Then A and B are said to be disjoint sets. So what does this really mean? This really means to say, guys, that these two sets, are disjoint. So this is what this practically means. Say you have this, okay? Say you have this, then you have set A, okay, and you have set B. What do you really see? Because A intersection B is a null set, what does this show you? That there is no intersection. There is no intersection at all. The intersection is not there. There is no intersection. So this intersection in disjoint sets, the intersection is a null set, okay, meaning it's an empty set. So this is a disjoint set is an example of an empty set. So you see, you've got another example here. So this is what a disjoint set is. This is all it is. It's a very simple set, but the name can creep you out. The name can creep you out. It can give you the skeeves. If you're American, you know what skeeves means. Or if you've watched Drake and Josh, you know what it means. But anyways, it's a very creepy set, But now, let's move on to our next set, which is difference of two sets. So now let's move on. So let me just see. Okay. Yes, perfect. Okay, there we go. Perfect. Just give me a second, guys. Perfect. Okay, so now we're going to move on. Now we're going to move on. So let's really look at something else. Okay. So now difference of two sets. Okay, and then we move on to complement of a set. Okay. So so difference of two sets. Okay, difference of two sets. So okay, let's assume A and B have two different elements. Okay, let's assume A and B, okay, have two different elements. Okay, A and B have two different elements where where element A does not belong to element B. Okay, where element A does not belong to element B. So that's basically the difference of two sets. Okay, where element A does not belong to element B. So basically the difference of two sets, guys, is this: A minus B. Okay, this is the difference between the two sets. So just copy this down right now, and I'm sure I think it's self-explanatory, where element A does not belong to element B. Now if you still don't understand this, just don't worry, don't panic, and don't sweat it, because like I said, anything which I don't explain or which is unclear to you or unaddressed right now, later on, like I said, once I do questions, you will start to find it a little more clearer. So now we are going to focus on complement of a set. So now guys, complement of a set is a little more complicated than this. So I'll need your absolutely undivided attention on that. So let's move on. Okay, let's move on. Okay, good job. So now we're moving on, guys. Okay, so don't really worry if you didn't understand this yet. Don't really worry about that. You will very, very soon understand it. So complement of a set. So what is a complement of a set? Okay, so what is a complement of a set? So if I didn't know what a complement of a set is, I think it would just be trying to give feedback to any sort of set, or just trying to praise that set by giving it positive feedback. But obviously, if you are a mathematician, then you will say no, complement of a set is something more mathematical, not something to do with common sense or common knowledge. This set is an example where common sense is not necessarily always common. Don't worry, if you're a logician, you'll understand what I mean. And if you're not a logician, you'll think I'm defying your treatment. Don't worry, it's not a problem. Anyways, let's move on. So now listen very carefully and focus, undivided attention. This is a very convoluted sort of set, so you have to listen. Okay, let's just hope that the camera doesn't blank out. If it does, tough luck. Okay, so let's assume U. Okay, let's assume U is a universal set. Okay, a universal set. Oh God, can't really see the A there. Okay, let's assume U is a universal set. Okay, a universal set. And A is a subset. A is a subset of U. A is a subset of U. Then the complement. Then the complement. Okay. Complement. The complement is the set of elements in U and not in A. Okay, it is the opposite of a subset. Okay, guys. The opposite of a subset. Okay, so it is opposite of a subset. So do you guys know what this means? So let's go through it. Let's assume U is a universal set and A is a subset.